In this section, let's look at two trigonometric limits that we will need later when looking at derivatives, namely at the limit for x going to 0 of sine of x divided by x, and the limit of x going towards 0 of 1 minus cosine x divided by x. In both cases, we see the sine of x when x is 0, so we have 0 divided by 0. And the cosine of x, for x being 0, the cosine of x is 1. So 1 minus 1, we get again 0 divided by 0. So we need closer inspection of that. Since we're talking about sine of x and cosine of x, x is an angle. And when we're talking about trigonometric functions, the x is always measured in radians unless stated differently. So just some reminders about trigonometry and radians. Remember the unit circle, that's the circle with length of radius being 1, and actually the 0, 0 being the center, which is not important here. The definition of the radian is, it is the length of the arc of the unit circle of the sector with this central angle alpha. So if we have, for example, the central circle is 360 degrees, which means, so here 360 degrees would be the full circle. So the arc length is obviously 2 pi, since the radius length is 1. 2 pi r is 1, so we get 2 pi. For 180 degrees, half the circle, we get obviously then just half of it, so pi. For 90 degrees, we get pi half. And for example, for 60 degrees, it's just a sixth of the full circle, so it's a 6 of the 2 pi, so we get pi third, and so on. The formula for the area of a sector with central angle x, so this sector here, for example, central angle x, the arc length is x, the radius is r, so the formula for the length of for the area of the sector is radius times the arc length divided by 2, so 1/2 times the x times r. And now let us look at a central unit circle with some arbitrary central angle x. And for that central angle, let's once look at the corresponding sector here. Then let's look at this triangle by going from this point here vertically down to the x-axis, and then let's extend this line here such that we get this triangle, this right triangle here. So when we look at it, we see the small triangle is obviously smaller than the sector, and this is smaller than the area of the large triangle. And now we're going to use this to show in the end what the limit of sine of x divided by x is. So this is what we just said before. Now, using the fact that the area of a right triangle corresponds to the product of the length of the two cathetas divided by 2. So we use that one for the area of the small triangle of this triangle here. Well, if this is x, then by definition, this here is the sine of x, and this is the cosine of x. So the area of this triangle is just 1/2 times the sine of x times the cosine of x. The area of the sector, as we said before, is 1/2 times x times the radius, so times 1. And the area of the large triangle is this length. This is 1 times the tangent of x, this length here. And so we get to this inequality. And now try on your own to understand step by step what is happening, how we proceed. And here come now the solutions, also step by step. So the first transformation, we just multiply by 2, and we replace that tangent of x is sine of x divided by cosine of x. In the next step, we divide by sine of x. So we get here cosine of x, x divided by sine of x, and here the sine of x disappears. That's how we get the next line here. Now, obviously, all that we're doing is we're just introducing the limit. And now we use that the limit of cosine of x, when x is going to 0, the limit is 1. So we get here 1. And here we get 1 divided, well, this by 1. So we get also 1. So since 1 is smaller or equal to this limit, and the limit is smaller or equal to 1, there's only one possibility, that this limit has to be equal to 1. Well, if the limit x divided by sine of x is 1, then obviously also the limit of sine of x divided by x, so inverting these two, is 1. We can do it formally also. Limit of sine of x divided by x is the limit of 1 divided by now x divided by sine of x, and that we have shown here is 1. So 1 divided by 1, we get 1. So we have proved this first limit, sine of x divided by x, when x goes to 0, is 1. Now let's look at the limit of 1 minus cosine of x divided by x. Here you have all the transformations and try to follow what it is. Think about what is happening at this equation and here, and then we have also a look at what is happening here. So, what is the 1? Well, in the 1, what we do is we use this trigonometric identity that sine squared of x plus cosine squared of x is always 1. We solve it for cosine of x, so we get cosine of x is the square root of 1 minus sine squared of x. And now what happens in step 2 here? Well, we just apply the third binomial formula. We expand by this expression here, this whole expression. And when we expand this here by this, we have exactly the third binomial formula, a minus b times a plus b. So we get a squared is 1 minus b squared, which is this here without the square, so 1 minus brackets 1 minus sine squared of x. So this here it's clear, that just simplifies to sine squared of x. Then from here to here we just write it as a product of two fractions, splitting the sine squared of x into sine of x times sine of x. And now how do we get this here? Well, what do we know here about the sine of x and the sine squared of x? They both go to 0. And what do we know about this expression here, sine of x divided by x? That's what we just proved a minute ago. The limit here is 1. So we get 1 times here 0 divided by this here, and so in total we get 0. So we found the limit of 1 minus cosine of x divided by x is 0 for x going to 0.